Welcome to ERC Tipsnology. This is day 2 of our microcontroller tutorial. Let's start. Inside the CPU, there are ALU flags, program counter, instruction register, instruction decoder, timing, and control. Registers A, B, C, and D, and all of these are connected to the address bus, control bus, data bus, and some internal bus. ALU stands for Arithmetic or Logic Unit. ALU performs arithmetic functions such as add, subtract, multiply, and divide, and logic functions such as and, or, and not. Program counter points to the address of the next instruction to be executed. As each instruction is executed, the program counter is incremented to point to the address of the next instruction to be executed. Instruction decoder interprets the instruction fetched into the CPU. A CPU, to be capable of understanding more instructions, requires more transistors to design. Microcontrollers and embedded processors. General-purpose microprocessor contains no RAM, no ROM, no I/O ports. On the other hand, microcontroller has CPU, which is the microprocessor itself, RAM, ROM, I/O ports, timer, ADC, and other peripherals. A general-purpose microprocessor does not have RAM, ROM, I/O port, timer, or serial COM port. These devices are just connected to it through the data bus, address bus, and control bus. The microcontroller, on the other hand, has the following devices inside: CPU, RAM, ROM, I/O, timer, and serial COM port. For the general-purpose microprocessors, we must add RAM, ROM, I/O ports, and timers externally to make them functional. This makes the system bulkier and much more expensive. But it has the advantage of versatility on the amount of RAM, ROM, and I/O ports. For the microcontroller, the fixed amount of on-chip ROM, RAM, and number of I/O ports makes them ideal for many applications in which cost and space are critical. In many applications, the space it takes, the power it consumes, and the price per unit are much more critical considerations than the computing power. An embedded product uses a microprocessor or microcontroller to do one task, and one task only. There is only one application software that is typically burned into ROM. A PC, in contrast with the embedded system, can be used for any number of applications. It has RAM memory and an operating system that loads a variety of applications into RAM and lets the CPU run them. A PC contains or is connected to various embedded products. Each one peripheral has a microcontroller inside it that performs only one task. Examples of microcontrollers for embedded systems: home appliances, intercom, telephones, security systems, garage door openers, answering machines, fax machines, home computers, TVs, cable TV tuner, VCR, camcorder, remote controls, video games, cellular phones, musical instruments, sewing machines, lighting control, paging, camera, pinball machines, toys, and exercise equipment. Office, telephones, computers, security systems, fax machines, microwave, copier, laser printer, color and printer, paging. Auto, trip computer, engine control, airbag, ABS, instrumentation, security system, transmission control, entertainment, climate control, cellular phone, keyless entry. Many manufacturers of general-purpose microprocessors have targeted their microprocessor for the high end of the embedded market. There are times that a microcontroller is inadequate for the task. When a company targets a general-purpose microprocessor for the embedded market, it optimizes the processor used for embedded systems. Very often, the terms embedded processor and microcontroller are used interchangeably. One of the most critical needs of an embedded system is to decrease power consumption and space. In high-performance embedded processors, the trend is to integrate more functions on the CPU chip and let the designer decide which features he or she wants to use. In many cases, using x86 PCs for the high-end embedded applications, it saves money and shortens development time. There's a vast library of software already written, and Windows is a widely used and well understood platform. Choosing a microcontroller. Examples of 8-bit microcontrollers are Motorola 6811, Intel 8051, Zilog Z8, Microchip PIC. There are also 16-bit and 32-bit microcontrollers made by various chip makers. That's the end of Day 3 in our microcontroller tutorial. Please subscribe, share and click the notification bell for the next tutorials. See you again, here in ERC Tipsnology. Thank you, and goodbye.